Hello everyone, how are you all? And we will be working on today on question number 16 to 20 from the 2025 AMC 8 problems. So let's just begin. If you haven't watched the videos for the past parts, just do go watch questions 1 to 15 to know their solutions and understand the strategies behind solving questions efficiently and quickly. We will be beginning with in the parts with question number 16 today. Let's read through the problem. The question says five distinct integers from 1 to 201 to 10 are chosen, and five distinct integers from 11 to 20 are chosen. No two numbers differ exactly by 10. Now, this is something to note down that two numbers will not differ exactly by 10. So we have to make sure that we choose numbers in such a manner. For example, if I have chosen 3, I cannot choose 13 because then in that case they differ by 10. What is the sum of 10 such chosen numbers? So we have two lists here if you look carefully. It is from numbers from 1 all the way up till 10, and I have to choose 5 such integers from it. Similarly, I have the list from 11 to 20 and I have to choose 5 more integers from it. Keeping in mind that my numbers do not differ by 10. For example, if I'm choosing 1, I cannot choose 11. If I'm choosing 2, I cannot choose 12. So that the numbers don't differ by 10. Now, first thing that comes to my mind is to choose numbers. For example, what happens if I choose 1, 2, 3, 4, 5? And instead of choosing the first 5 set from the next set of integers, which means instead of choosing 11 to 15, because I have chosen 1 to 5, it eliminates my 11, 12, 13, 14, 15. I cannot pick up an 11 or I cannot pick up a 12, cannot pick up 13, 14, and so on. But I can only pick up the next set of integers from 16, 17, 18, 19, and 20. This is one such possibility that I can do. In such a case, what happens is that my criteria given in the question has been satisfied and hence I do not have to worry about how do I solve it. Another possibility could have also been that I would have chosen numbers, let's say, this is my first case and this would work and satisfy the condition. Another way I could have gone about the question was, what if 6, 7, 8, 9, and 10 were chosen from the first set of list? And then now, because I have chosen 6, I cannot choose 16, 17, 18, 19. So I'll have to pick the first 5. That is 11, 12, 13, 14, 15. Now, if you might ask that whether above 1 is the answer or below 1 is the answer, both are my correct answers because both satisfy my criteria given in the question. Now, the question says, what is the sum of the 10 chosen numbers? Then you can quickly add on the numbers and see what is the result that you're getting. One way is to go about it manually and add them. For example, 1 plus 2 plus 3 plus 4 plus 5. Now, you know when we are doing 1 plus 2 plus 3 plus 4 plus 5, that's the sum of the first 5 natural numbers. We have the formula n times n plus 1 divided by 2. So 5 times 6 divided by 2. For 16, 17, 18, 19, 20, you can add manually also. That's one way to go about it. Another way that you can think of adding these numbers is that when you put them in a list, you can use the Gauss method to add them. If you know the Gauss method is to add the first and the last number. For example, 1 and 20 adds up to 21. Similarly, 2 and 19 also adds up to 21. 3 and 18 will also add up to 21. So you will get 5 such pairs of getting. So your clubbing numbers 1 and 20, 2 and 19, the first and the last, 3 and 18, and so on. And the last sum will be 5 and 16, which will also add up to 21. Now there are 5 such pairs which are adding up to 21. So 5 times 21, which is 105 is my answer. And if you might ask The next pair, if you look at, that also so far satisfies the same criteria. 6 and 15 adding up to 21, 7 and 14 adding up to 21. Here also the answer for the sum is also going to be 21 times 5, which is 105. So as we discussed, both are my answers. Whichever you take, the answer is going to be correct, because the question does not say you have to write down the pair of answer. You have to write down the sum of the answer. So hence my answer is going to be 105. The choosing of the pairs is easy. You just have to think about which pair is going to satisfy your condition. And in such a case, adding you can be quicker and faster, because now you're on the 16th question and time is less, right? So in such a case, you have to choose quick strategies to add first. Usually Gauss's method and some of natural number formulas help us do calculations or summations quite faster. So you must know such methods and remember them. Let's move on to the next question, which is the 17th question. Let's read through the problem carefully. Slightly a thinking problem, and the figure looks complicated as it would be a very difficult problem, but it isn't. So let's try making the problem easier for us. It says, in the land of Markovia, there are 3 cities, A, B, and C. 100 people who live in A, 120 people who live in B, and 160 who live in C. Because the question is giving me information side by side, I can keep writing so as to not forget. This is 100, this is 120, and this is 160. Everyone works in one of the 3 cities, and a person may work in the same city where they live. In the figure below, an arrow pointing from city 1 to another city is labeled with the fraction of people living in the first city who work in the second city. For example, if this arrow I look at, which is written with 1/4 as a symbol, it indicates that 1/4 of the people who live in city A work in city B. And similarly, the opposite arrow, 1/3, indicates 1/3 of the people from city B live in city A. So it's an easy question if you look at the diagram and understand its meaning quite carefully. The question asked to us is how many people work in A. So my center of attention is A. And if I look at the diagram carefully, I can see A has 100 people, B has 120 people, and how many people do we have in city C is 160. So we can note down that information. Now, based on the diagram that it has been given to me, I need to see that there are 4 arrows going from A. One is these people who are going to work in city A, city B. One is this arrow. Again, these people are also leaving city A because they're not working in city A. But there are also some incomers. So there is 1/3 of people who are coming to work in city A from here, from city B, and 1/8 of people who are again coming to work in city A from city C. So we have to remove the number of people. So we have to take the total people, remove the ones who are going to work in different cities, and we will add the ones who are coming to city A, because that will give us the total or the net number of people who are working in city A. First, let's calculate which are the ones which are going to different cities. So 1/4 from here, which are going to city B, and 1/5 are going to city C. So 1/4 of 100 and 1/5 of 160 are the people who are going to work in city B and C respectively. 1/4 of 100 is going to give you 125, and 1/5 of 160 is going to give you 32. This gives you the answer as 57 people who are going to different cities to work. Now, if we go on ahead, sorry, this will be not of 160. This will also be of 100 only, because these are, now this is a mistake that you might also make, which is that there are people from city A who are going to work in different cities. So 1/4 is not of B, it is of city A. 1/4 of the people of city A are going to work in city B. 1/5 of the people of city A are again going to work in city C. So it is dependent on city A. That's why we're taking it of 100. So this gives me 25 and 20, which is 45. So 45 is the number of people we will subtract from the total people. Coming on to how many people are coming to city A. Now this is dependent upon B and C because the arrow is coming in from B and the arrow is coming in from C. So 1/3 of city B, which is 120, they are going to work in city A, and 1/8 of 160, they are going to work in city A from C. So 1/3 of 120 will give me 40. 1/8 of 160 will give me 20. This gives me a total of 60. Now all I have to do is just take 100, subtract the ones which are going out and add the ones which are coming in. So 100 minus 45 plus 60. I hope you understood why we are subtracting 45 and why we are adding a 60. 45 is the number of people going out. 60 is the number of people coming in to work in the city. And my total answer is going to be 150. So total people going to the city, coming to the city, you subtract and add. That's how you get through the answer. It's an easy problem, just understanding the diagram quite carefully. So my answer to the problem here is 150. I hope you've understood how we have interpreted the diagram quite carefully. It's just the meaning of the diagram and the calculations to be done quite easily. Once you understand the diagram carefully, it is very easy to go about the problem, and it is a 17 number problem which can also be done only in 2 minutes. Let's understand now the 18th problem. Let's look at it. It says the circle shown below on the left has a radius of 1 unit. The region between the circle and the inscribed square is shaded. In the circle shown on the right, 1/4 of the region between the circle and the inscribed square is shaded. The shaded region in the two circles have the same area. What is the radius r in units of the circle on the right? So we have one circle and square where the radius is given to us, and there's a shaded region. We have another circle, but its radius is not known to us. However, its shaded area is given to us, only a quarter of what has been shaded in here. This means, and remember the radii are different, so the areas are different. And a comparison between the two is that the area of the first one is exactly equal to the area shaded in the second figure. How do we calculate the radius of the circle is the question. So we will have to do some calculations here. And the calculations can be done by writing down your working because it is relative to area of squares, area of segments, and so on. So we'll try and work that out. First thing must be to calculate the known area to us, which is this area, because here the radius is also known to us and we can look at the area of the shaded region. So area of shaded region in the first diagram, we will calculate first. To calculate the area of the shaded region in the first diagram, it is very easy. We have to calculate area of circle and subtract from it the area of the square. Once we do that, we will get our answer. Area of circle will be pi times radius square, which is 1 square, minus. Now we have to look at here that how do we find out the dimensions of the square? Because this is 1, we can also make another line like this, which will be right angle to the same line. This will also be the radius 1. Using Pythagoras, the side of the square can be 1 square plus 1 square under root, which is root 2. So the side of the square in this case is root 2. So area of the square would be root 2 square. Hence the area of the shaded region is pi minus 2. So we have used the formula for area of circle, area of square, subtracted both of them to get the area of the shaded region, and we have calculated the side of the square using Pythagorean in this case because I can see a right angle form. Also, just to think about why is it a right angle is because it is the diagonals of a square would bisect at right angles, right? That's why I get that 90-degree angle. That property of the square would help us do that. Now my aim is to, I have calculated the area of the shaded region from the first one. Now my aim is to calculate the area of the shaded region. We might not be able to calculate the exact shaded region in the second case, but we will compute it in terms of R. Now, we have A of shaded region in the second one. It is 1/4 of the way that we did. So whatever we did right now, all we have to do is do a quarter of it every time. So which is 1/4 of area of circle minus area of square. That way also we will get our answer. But now remember, the dimensions of the square and the circle in this case will change. So 1/4 of area of circle will be pi times r square minus area of square. Now let's look at the dimension once again. Similar calculation we will do. We will do r square plus r square root, which will give me 2r square within the root. R square can be brought out of the root using Pythagoras, so r root 2. And when I square the area, it's going to be 2r square. So that's the area of the second shaded region that I have got. And now all I have to do is compare both the regions to calculate my answer for r. To simplify it as well, we can take out r square common in it, divided by 4. I will be left within the bracket with pi minus 2. This will make my calculations a bit easier to take out a common factor. Now compare both the areas, because in the question it says both the areas are equal to each other. So pi minus 2 is equal to r square by 4 times pi minus 2. Since pi minus 2 is on multiplication on the right hand side, we can directly cancel it. I'll be left with 1 is equal to r square by 4. It's directly cancellation of the two factors of pi minus 2. It's basically pi minus 2 being divided on the other side. Because it's a quantity, we can do that. Makes our calculation very, very easy. Makes it r square is 4. R will have a value plus minus 2 because obviously r cannot be negative. The value of r is 2. I hope you have understood how we have done the calculation for such a question, where we have taken the shaded region and calculated shaded region in both the cases and calculated our radius. So first we did area of the first region, area of the second region, equated both of them, got my answer for the radius. One quick tip while understanding this kind of a figure is that in this case, using Pythagoras, we are trying to calculate the side of the square and relate it with the radius of the circle. That's how we got our answer for radius is equal to 2. Therefore, the answer is the B part in this case, which is r is equal to 2. So it was an easy question, but the whole idea is to do the longer calculation, which might take you some time. So in case you are not really good at geometry, you have to focus on such problems, because area of shaded region is a common question when it comes to questions from specifically from 18 onwards and 20, 22, 25. A lot of times you will also see easy geometry questions from 20 to 25 also. They will also make your calculations easier. So geometry is a concept that students fear, but it isn't something to fear. You can easily solve if you know the formulas. Now let's look at the 19th problem. It says two towns A and B are connected by a straight road 15 miles long. Traveling from town A to town B, the speed limit changes every 5 miles from 25 to 40 to 20 miles per hour. Two cars, one at town A and one at town B, start moving towards each other at the same time. They drive at exactly the speed limit in each portion of the road. How far from the town in miles will the two cars meet? And so the problem is easy. Let's understand it first. A to B, you have been given a stretch of a road. On top, the speed limits have been given in each of the case, like 25, 40, 20. That in the first stretch, you can only drive at 25 miles per hour. Second stretch, you can drive at 40 miles per hour. And the third stretch, you can drive at 20 miles per hour. Then in the distances of these stretches are equal stretches because they are 5 miles, 5 miles, 5 miles. Now the question says there's a car here at A, there's a car here at B, and they move towards each other in opposite directions like these. Now question says if they start driving at the same time, we know the speed limits they will drive at, we know the distances that they will drive, but we might not know at what point in the middle they might not meet exactly in the middle because the speeds are varying. Here, if you see, this speed is faster while the speed is slower. So they might meet somewhere in the middlemost stretch. However, where they will exactly meet is not known to us, right? So we have to calculate how far from A will the two cars meet, right? Where will they meet exactly? Also, because of the idea that this is exactly somewhat near about speeds, we know that this they will still cover the first stretch, but here them distances might vary. That one of them might cover some extra miles and one of them might cover some lesser miles, and they will meet at those points, right? So that's what we have to calculate, where will they meet. The question might look hard, but I will show you some easier ways to go about such questions, specifically speeds and times when they are moving towards each other. Now, first, let's see if I start moving from A and the second car starts moving from B. For the first stretch, how much time will it take? Because that will give me a comparison that to cover that same distance of 5 miles, how much time is it taking in each of the stretch? For example, if it is 25 miles per hour is the speed and the time is 5 miles per hour, I know the distance is 5 miles in this case. To calculate the time, I have to do distance divided by speed, which is 5 divided by 25, which is 1/5. So 1/5 of an hour, which is largely 1/5 times 60 to convert it into minutes. I will get 12 minutes it will take for the first person to cover the first stretch. If we do it for the second case, the speed is again 20. Distance stays the same, which is 5. Time will be 5 divided by 20, which is 1/4. To convert it into minutes, 1/4 multiplied by 60, which is going to be 15 minutes. So the first person, remember, will take 12 minutes here, and the second person, remember, will take 15 minutes here, right? So by that time the person reaches here, which is takes 15 minutes, they would have already covered 3 minutes of distance here. Now, instead of dealing with that 3 minutes of a difference, right, what we do is we assume that they take X more minutes to go on ahead, right? Or we say that they cover X distance, not the time. We can compare the distance. Also, remember when they are moving towards each other, right? What happens when two things move towards each other? Let's understand that. For example, if car A is here, car B is here, and they're trying to cover the same stretch, with irrespective of the different speed limits and distance limits that have been given here. For a normal question, if A and B are at two ends and they're moving towards each other, remember always they might not meet exactly in the middle. That's one thing you have to keep in mind. Students assume that they meet exactly in the middle, which is incorrect. So that must not be done, right? And then one more thing that you need to know is that in that case, the time taken, let's say they meet at this point, which may be somewhere around a 25%, 75%, that's not known to us. Time taken by A to reach the meeting spot and time taken by B to reach the meeting spot will be exactly the same. Moreover, the distances covered by both of them will exactly add up to the total distance of the spread, right? So what we've done is we have first calculated how much time is it taking from this to this for covering the first stretch for both of them. And now we will work on the time taken for them to cover the middlemost spread. Now we don't know how much portion of the middlemost stretch are they covering, except for we only know that there's a difference of 3 minutes in their times. We know that the time taken by A is exactly equal to time taken by B. Right? Because either they might meet at different points, but the idea is that the time taken by both of them will be the same. No, both of them will take the same time to reach that spot only, then they will meet. Right? Now we know A has already taken 12 minutes, or we can say 1/5 of an hour. And we know B has already taken 1/4 of an hour, which is 15 minutes. Right? Now we don't know how much of this 5 miles they are covering. So we are assuming from here It is covering X mile. It's able to cover X miles. And from here, it's able to cover how much miles? If that's X miles, then this much will be 5 minus X, right? And the speed limit is given to us. A takes 5 miles, X miles from there. Distance is X. Speed is 40. So X by 40 equal to 1/4 plus. Now B has to cover 5 minus X miles divided by 40, right? That is the equation that we are making out of X, which is the distance covered from both the sides, because that's what we ultimately want to know. We know 5 miles it has already covered, but we don't know how much of that middlemost stretch it has actually covered. So we take that as a variable and then compare their times, because that's exactly going to be equal to each other, right? One more way that you could have done it is their distances have to add up to a total of 15 miles. That's also something you would have taken into consideration, but time way it is easier. Now we can take an LCM of 40 on both the sides. This will give me 40. This is going to give me 8 plus X. Here also I can take an LCM of 40. This is giving me 10 plus 5 minus X. Easy to compare the equation. 8 plus X is 10 plus 5 minus X. This makes it 2x is equal to 15 minus 8. 2x is equal to 7. X is equal to 3.5. Now remember, 3.5 is not my answer, so don't be in a hurry of looking for your answer in the options. It has covered 5 miles from the start and 3.5 miles extra from this spread. So we can say the total distance covered by A will be 5 plus 3.5, which is 8.5 miles in total. So exactly when it starts covering from A, it will cover 8.5 miles to be able to get or meet the other car traveling from B. So the question was easy, but there was a lot more thinking as to where do you need to take a variable. And you have to always consider the cases or practice more questions of the cases where there are two cars traveling in the opposite direction towards each other. Because in such cases, there are a lot more possibilities or a lot more properties to know about the scenario. That is, the time taken for both of them is the same, and the stretch that they cover, it has to add up to the total distance. For example, if you look at the total distance we took for A and total distance that we took for B, has to add up to 15, right? Because it's 5 plus X and here it was 5 minus X plus 5. So both the distances are being covered by a our total add to up to a 50, right? Now this is something which is important and was a good question to solve for. Hence we get our answer in this case as the D part, which is 8.5 miles being covered by. So it was a good question that way. There's a lot more thinking about the problem, right? So we did a lot of bunch of questions which were slightly harder. However, they involved a lot of thinking. One thing that you need to keep in mind is to solve such problems with utmost care without being able to make a mistake in the calculations, and your ideas or your strategies that you're using specifically with relative to your concept have to be strong enough. So I hope you understood the problems and all the best.